Now let's talk about the polytropic process. Now polytropic process is given by PV to the power n is equal to C, where this term n is called the polytropic index. It is called the polytropic index. Now if you remember the adiabatic process, that was P into V to the power gamma is equal to constant, and in this the value of gamma, that was the adiabatic index, was 1.4 for the working fluid air. In the polytropic process, the value of n is about 1.2 to 1.3 for the working fluid air. Alright, so to compare between adiabatic process and a polytropic process, you can say that adiabatic is an ideal process and polytropic is an actual process. Okay, so this can be a general difference between the two processes. So this is how you would indicate a polytropic process on a PV plot going from 1 to 2, and this would be P1, and you'll have your volume as V1. Again, the pressure at 2 would be P2 and the volume at 2 would be V2. Now we all know that the work done in going from 1 to 2 is integral V1 to V2 into PdV. Now the law that governs this process is PV to the power n is equal to constant. So it will be P1 V1 to the power n is equal to P2 V2 to the power n is equal to PV to the power n is equal to C. And from this equation I can say that the value of P, let's find out the value for P in terms of P1 V1. So the value of P, this would become P1 V1 to the power n upon V to the power n. So let's substitute this value of P in this particular integral. So you will get P1 V1 to the power n. P1 V1 to the power n is a constant value, and inside the integral you would get V to the power minus n dV, and this will leave you with P1 V1 to the power n into V to the power n minus n plus 1 by minus n plus 1. So this is a similar thing as compared to the adiabatic process. So the mathematical expression will come out to be similar. In place of gamma you would have n in this case. So if you again manipulate it, this will become P1 V1 to the power n upon 1 minus n into V2 to the power 1 minus n minus V1 to the power 1 minus n. Let's take the negative sign outside and we'll get P1 V1 to the power n by n minus 1 into this, that is V1 minus V2. Okay, let's move forward now and multiply this term with this term and replacing P1 by P2 and V1 by V2, and then multiply this with this term. So we will get P1 V1 to the power n into V1 to the power 1 minus n minus P2 V2 to the power n into V2 to the power 1 minus n by n minus 1, and this will leave you with P1 V1 minus P2 V2 upon n minus 1. Now similarly I can say, as compared to the adiabatic process, PV is equal to MRT, isn't it? Is equal to MRT. So I can replace P1 V1 by MRT1. So this would become W12 is equal to MR, it's a constant, T1 minus T2 by n minus 1. So these two expressions, that is the work done for adiabatic and the work done for polytropic. They are almost similar. The only difference is in adiabatic you have gamma over here, and in this you have n over here. So this index, in this case, this being the polytropic index, is the only difference in this expression. So this was the work done for a polytropic process. Now let's move on to the next video and talk about the free expansion process, and let's calculate the work done in the free expansion process.